right, today we're going to review for the activities 23 and 24 quiz. So if we are looking at the first set of problems where it asks you to write the rule for g of x equals f inverse of x. So I don't like how they do the whole g of x thing, but it wants us to write the rule for g of x equals f inverse of x. So you have two different types in this particular set. You have ones like number 5 where you've got f of x equals 5 to the x. So meaning your original is an exponential function and we're trying to find the inverse. Now at this point, because you should know that logarithms and exponentials are inverses, this is one of the only times this year that I will tell you that if you just know the answer, you can write it. If you don't just know the answer, then we have to go through the same process that we always have for finding inverses. And that is, first we replace the function notation with a y, then we switch x and y, and then we need to get y by itself. Well, to get y alone, we need to bring it down from its exponent tower, which means we would need to take the log on both sides. Now, deciding what log to take depends on what the base of the exponent is. Since the base of the exponent here is 5, you would have to take log base 5 on both sides, because when I do that, remember that the rule is that when the bases match, you can cancel those, and just whatever's in the exponent is what that simplifies to. So y is now alone, and you've got log base 5 of x. So f inverse of x or g of x, whichever one you put here is fine, would be log base 5 of x. So log base 5 of x is the inverse of 5 to the x. Now, that's one way when you start with an exponential and you come up with the inverse, which is a log. The other way is when, like in number 8, you start off with a logarithm and you have to find its inverse. So again, this is a case where if you just know the answer, that's fine. Write it. I'm totally fine with that. If you don't, again, same work. Put y in where f of x was, then switch the x and the y, and now solve for y. Now, to get out of a logarithm, you have to do the swoop method. So we need to write what the base is here since it's not written. We know that when you have a natural log, the base is always e. So when you swoop, you start with the little base, you go around, pick up an exponent, and it equals y. So e to the x equals y is how you would swoop on that, which means now that y is alone, that for number 8 is your f inverse. F inverse of x would be e to the x. So that's your first set. Then the next ones, 9 and 10, very similar, just one's a log, one's an exponent, but the key is that when the base of the logarithm and the base of an exponential match, that it cancels out and whatever is the big number or the exponent becomes your answer. So like in number 10, you've got 12 raised to log base 12 of x. Because this 12, the base of the exponent and the base of the logarithm match, those cross out, and it's just whatever is up here is your answer. Now, please keep in mind, because Springboard, this is one case where they didn't do a very good job of giving you a good variety, and most of the answers in Springboard were always x. Remember, it's not always just x, it's just whatever is left here. So if you had log base 7 of 7 to the 5y, again, base of the logarithm and base of the exponent match, so those would cancel and you would just get 5y. So I wanted to do that extra example to re-illustrate that for you. All right, the next sections really are the same thing that we did in the previous two activities and on the 21 and 22 quiz, except that the base is different, and that's where it asked you to take what was an exponential statement or equation and write it as a logarithmic equation and vice versa. So I'm just going to look at a couple of those. So if you look at number 14, you've got 2 to the negative 3 equals 1/8 is your original. Again, directions, you're supposed to write them as this as a logarithmic equation or statement. So when you do that, you write log, and it's whatever base the base of the exponent is. So log base 2 of whatever was on the other side, so in this case, 1/8, equals whatever the exponent is. So this is your answer there. There's really, not work to do. It's just you have to have memorized the pattern. If we want to go the other direction, let's look at, say, number 16, where we're having a different base here. So same idea, we're writing it as a logarithmic equation now, but remember, we don't write log base e. Some people keep writing log base e of 2 equals 3 to the x. If you write this as your first step, I'm okay with that, but you absolutely cannot leave log base e as an answer. Log base e is natural log by definition, so you have to write it this way. Natural log of 2 equals 3x would be the logarithmic statement in that case. So the other direction would be when we have a logarithmic statement and we want to write it as an exponential. So an example of that would be number 23, where we've got our logarithmic statement to begin with. Log base 2 of 64 equals 6. And again, when you go from a logarithm to an exponential, that is your swoop method. So you start with the little base, which is 2, swoop around to pick up the exponent, and then equals the big number. So 2 to the 6th power equals 64. And that's it for those. Next section was even more of review of the exact same properties that we went over in activities 21 and 22, except now with a base that was something other than 10. So it's the same properties that we went over in 21 and 22, your product property, your quotient property, your power property. So if we look at let's look at number 26, where we've got log base 4 of x to the 8th over 5. So directions here, you had to expand it. So when you're expanding, you're using the properties and making it longer. So you're separating it into multiple logarithms. So division, you should know, separates into subtraction. Base stays the same. So log base 4 of x to the 8th minus log base 4 of 5. Numerator minus denominator. Then you look at each of those logs and see if they simplify any further. This right here is a power, so your power property tells you that that can become a coefficient. So 8 log base 4 of x would be the simplified version of this, and then minus log base 4 of 5 because there was nothing else to simplify there. So that's an example of expanding. Then remember that you also need to be able to condense. So that's what you have in, let's look at number 30. Log base 2 of 32 plus log base 2 of 2. And the directions are so important, guys. The directions here told you to write this as a single log. It did not say to evaluate. So when you do this, you should know, this is the only property we haven't reviewed, 26, we reviewed 2 of the 3, that when you have addition of multiple logs, as long as the bases are the same, that you can condense that into a single logarithm using multiplication. So 32 times 2 is 64. Yes, I know that you could evaluate that, but the directions did not ask you to evaluate. It asked you to write it as a single logarithm. So this is all you need to do there. All right, now the next one asks you to do some evaluating. So in 36 and 37, so I'm going to look at 37, which was log base 3 of 81. Now remember, you are going to have to show a step of work on this. You can't just write the answer. This is not change of base formula. This is the actual rewriting bases, because 81 can be rewritten in base 3. So 81 is 3 to the 4th power, and so I can evaluate it without a calculator, because when the bases match, these cancel, remember, and the answer is just whatever your exponent was, which is 4. All right, now moving on to the change of base formula that some of you probably wanted to use in 37 but can't. So 38, change of base formula, it asks you to rewrite it first. So you had log base 4 of 20. When you use change of base formula, it's common log of the big over common log of the small. Remember, when I say common log, that means log base 10, because many of your calculators don't have the option to where you can have a button with a log of a different base, but they all have a log base 10 button. So once you've written this, and this has to be on your paper for the quiz, once you've written this, shown that you know change of base formula, then you can actually press into your calculator log of 20, don't forget to close the parenthesis, then hit divided by, log of 4, close the parenthesis around the 4 again. You should get 2.161 for your answer there. All right, the rest of the problems had to do with either exponential growth, compound interest, or solving equations. So we're going to do at least one type of each equation, and then we're going to look at one of the interest formulas as well. So first one I want to look at is 2b. You have 8 times 3 to the x equals 216. You are allowed to use a calculator on this. What I don't want you to do, people who don't study and don't pay attention always tell me that 8 times 3 is 24, and they rewrite this 24 to the x equals 216, and then they can't figure out what to do. You can't do that. Order of operations prevents you from doing that because your x is in the exponent. You have to get the exponential by itself first by dividing both sides by 8. So 3 to the x equals 27, because that's what you get when you take 216 divided by 8. So 3 to the x equals 27. Then you just have to rewrite 27 to match base 3. So 27 is 3 to the 3rd. Once you make the bases match, then you can set the exponents equal. So x equals 3. You can double check, plug it in, make sure it's not extraneous, and that one does work. So that's one type where you're able to rewrite the bases as the same and then solve. Sometimes we're not able to rewrite the bases so that they match. So if we look at 2h, for instance, you have 3e to the 5x equals 42. So starts out the same. I need to divide by that 3 first in order to get my exponential part by itself. 42 divided by 3 is 14. And now I can't rewrite 14 in base e. It's not a power of e. So I need to then, the other method that we learned when you can't rewrite them in the same base is to then take the log of that base on both sides. So log base e is the natural log. So I need to take natural log. Whatever I do on one side, I must do to the other. So I do it on the right side as well. Because on the left side, since this is base e and the exponential is base e, those cancel, and I've just got 5x. So 5x equals natural log of 14. So you can press natural log of 14 in your calculator and then divide it by 5, and that is how I got my answer of x is approximately 0.528. We'll look at 3c. You have 3 to the 2x plus 1 minus 5 equals 80. So again, exponential has to be by itself first. So first thing I do is add 5. So 3 to the 2x plus 1 equals 85. Again, this is another case I can't rewrite 85 in base 3 because 85 is not an even power of 3. So that means I'm going to have to solve this by taking the log, in this case base 3, on both sides. So log base 3 of 3 to the 2x plus 1 equals log base 3 of 85. Make sure you remember to take it on both sides. You can't change one side of the equation without doing the same thing to the other. So these will then cancel, and I've just got 2x plus 1 equals log base 3 of 85, which is approximately 4.0438. So then subtract 1. And remember, in your calculator, you're not actually rounding this. I'm writing it because I have to round somewhere when I'm writing. But in my calculator, I'm just pressing -1, enter. And then I'm pressing directly divided by 2. I'm not rounding in between. If you round in between, your answers are going to be off a little bit. And that is a small deduction. You need to keep exact answers as you go through. All right, so that should help you out on solving the exponentials. Again, some we can rewrite the bases, some we have to take the logarithm on both sides. Now we're going to look at number 6, which it asks how long it would take to double a $4,000 investment if you're earning 7% interest compounded continuously. So continuously compounded interest is the new formula. Number 5 is the same one we did at the very beginning of the unit, where it's just regular old compound interest. But number 6, it's continuously compounded interest, where we've got A equals, we call it the PERT, P-E-R-T. So if it says it wants to double it, that means I want my final amount to be 8,000. P stands for principal, meaning what did I put in? I put in 4,000. E is the number E. It's not a variable. You're not plugging something in for it. R, 7% as a decimal, is 0.07. T is my variable because the question asked how long. So if I'm going to solve this, first thing I need to do is divide both sides by 4,000. So 2 equals E to the 0.07t. Again, we're past the point where we're guessing and checking here. Now I know how to solve this. I can't rewrite 2 in base E, so that means I need to take the natural log, because that's log base E on both sides. So natural log over here and natural log over here. So these cancel, and I've just got 0.07t equals natural log of 2. So press natural log of 2 into your calculator, and then divide it by 0.07. You should get T is approximately, I don't know why I wrote 2, it's 9.902. So if we're talking about T, which is measured in years, it's going to take us 10 years to double that investment. All right, almost there. We also learned how to solve logarithmic equations. So for instance, number 9, I'm going to look at 9D, where we had log base 6 of 4 plus log base 6 of x plus 2 equals 1. Now, I tried to pick a trickier one here because there's 2 logs on the same side. You can't have that in solve. You have to condense it. So this is where our properties come into play. Since this is a plus, I know that I can condense that to a single log because they have the same base by using multiplication. So 4 times x plus 2, which would be 4x plus 8. Do not forget to distribute there when you apply your properties. So now that it's a single log, we solve logarithmic equations by swooping. So 6 to the first equals 4x plus 8. So 6 to the first is just 6. So subtract 8, which gives me -2 equals 4x. Divide both sides by 4. x equals negative 1/2. Do not forget on these logarithms, you cannot take the log of a negative number. So make sure you plug it back in that it's not going to give you log of a negative. Negative 1/2 plus 2 is positive 1.5. So this one works out okay. But remember that you do have instances where you end up with extraneous solutions. So make sure you check it. So that's one type of logarithmic equation where you can get it to be a single log and then swoop. The other type is when you have two logs on opposite sides. So that'd be like 9c, where you have log base 7 of 5x plus 3 equals log base 7 of 3x plus 11. When you have the same logs bases on both sides, remember those just cancel. So now this is just a simple pre-algebra, algebra 1 equation, 5x plus 3 equals 3x plus 11. So subtract 3x on both sides and subtract 3 on both sides, so you get 2x equals 8. Divide by 2 and x is 4. Again on the logs, don't forget to plug it back in and make sure that it works. All right, very last thing, make sure you can use your graphing calculator, and that would be on 11a and b. So on 11b, you had log of x plus 7 equals x squared minus 6x plus 5. We can't use our other strategies here. You can't swoop. It just ends up being something that you can't really solve. So you have to use your graphing calculator. So in your y1, you type in the left side. And this is log base 10, so it's just a regular log you're typing in. And then in your y2, you're typing in x squared minus 6x plus 5. Find an appropriate window. I think a standard window works for this one. But you end up with the parabola, that's your y2, and then your log graph looks something like this. And so all we're then doing is using our intersect feature, second trace intersect, to find those two solutions. So second trace, choice 5, first curve, second curve, make sure you find both of the intersection points. So 0.788 is the first one, and the second one was about 5.256. All right. So that covers at least one of everything that you're going to need to be able to do on your very last quiz of the year. Happy studying!